In this video, we're going to talk about solving quadratic equations. And when I say quadratic, the definition of quadratic is a second degree equation or an equation that has the highest exponent of 2. For example, ax squared plus bx plus c equals 0. That's a quadratic equation. It's an equation with a 0, and it's in standard form if 0 is on one side. And this is the second degree, or my highest exponent is 2. That would be square, and the word quad means square, so that's where the word quadratic comes from. The steps for solving a quadratic equation are: number 1, write it in standard form by setting one side equal to 0, and make sure your x squared term has a positive coefficient. Number 2, you're going to factor the side that is not equal to 0. Number 3, you're going to set each factor equal to 0. This is using the zero product principle. If you have two things being multiplied together and they equal to 0, then either the first one is 0 or the second one is 0, or both of them equal 0. So you're going to solve each equation. You will find two answers, and then you're going to check your two solutions. So let's look at our first example here. We're going to solve x squared plus 11x plus 30 equals 0. So it's already equal to 0, and since this is a second degree equation, I'm going to look for two answers by factoring this trinomial. Trinomials factor by using a t-chart. On the left side, we're going to put a times c. A is 1. C is 30, so 1 times 30. And on the right side, we're going to put B. B is 11. And then we're going to think of all the ways to multiply to get 30. Well, you've got 1 and 30, but that will never add or subtract to give me 11. You've got 2 and 15. If I add those, I get 17. If I subtract them, I get 13, so I'll never get 11 there. 3 and 10. If I add those, I get 13. If I subtract, I get 7, so that combination won't work. And then 5 and 6. And oops, if I add those, 5 plus 6, I get 11. So this is the combination I want to use. So I'm going to use that 5 and that 6 to split 11x up into two terms, positive 5x and positive 6x. Then from there, I'm going to bring down the last term, which is positive 30, and the first term, which is x squared. And now I have a 4-term polynomial. Don't forget it's equal to 0. And we're going to use grouping to factor this 4-term polynomial. So we're going to group the first two together. The smallest number in this group is 1, and the smallest variable in this group is x, so I'm going to divide out a 1x from both terms. X squared divided by x is x. 5x divided by x is 5. So I end up with x times 5 plus x. And then I'm going to factor out what the second two terms have in common. The smallest number in this group is 6, and 6 does divide into 30, so I'm going to factor out a positive 6. That will leave me 6x divided by 6 is 1x. 30 divided by 6 is positive 5. And now I know I did this right because I have a common binomial in each group, so I'm going to factor that common binomial out of each group. So I'm going to bring it out in front. When I take it out of this group, I'm left with an x. When I take it out of this group, I'm left with a positive 6. And so now I have factored this trinomial to x plus 6, x plus 5. This is factoring. The difference is now it's equal to 0. So now I have two things being multiplied together, and they equal 0. So that means that either this binomial, x plus 5, equals 0, and we'd have 0 times whatever x plus 6 is, and that would give us 0, or this binomial, x plus 6, equals 0. So I'm going to solve each one of these equations. To solve x plus 5 equals 0, I would subtract 5 from both sides. One of my answers is negative 5. And then this one, to solve x plus 6 equals 0, I would subtract 6 from both sides. So I would have minus 6 on both sides. And I would get my other answer is x equals negative 6. So my two answers are x equals negative 5 and x equals negative 6. Okay, let's look at example 2. In example 2, we have y squared minus 36 equals 0. This is a quadratic equation because my highest exponent is 2. So I have to set it equal to 0, and it is equal to 0. And then I have to factor y squared minus 36. Well, this is not a trinomial. It's only 2 terms, so I don't do a t-chart. With 2 terms, you look for your 2 conditions. It must be subtraction, and it is subtraction. And they must be perfect squares. So 2 terms, we're looking for 2 conditions, subtractions and squares. If it has both of those conditions, then it can factor to 2 parentheses. So we're going to factor this to 2 parentheses equal to 0. The first terms will multiply to give me y squared. That would be y times y. The second terms will multiply to give me negative 36, and they must be the same number. And that would be 6 and 6, so I would need a positive 6 and a negative 6. And I have factored this, now I have factored this into 2 factors. Then now we have it equal to 0, so we're going to take each factor, y plus 6 equals 0, and y minus 6, set each factor equal to 0. Use that to find our 2 answers. To solve this one, I would subtract 6 from both sides. I get y equals negative 6. That's one of my answers. For this equation, I would add 6 to both sides, and I get y equals positive 6. So my 2 answers are negative 6 and positive 6. Now we're going to look at example 3. In example 3, this one is a second degree, so it's a quadratic equation. Highest exponent is 2. I'm looking for 2 answers. It's not a trinomial. It is 2 terms. It is subtraction, but it doesn't meet my 2 conditions, subtraction and squares, because 3 is not a perfect square and neither is 75. So if it doesn't meet your 2 conditions, then you need to back up a step and look to see if both the terms have anything in common. And they do, because I can divide both of these terms by positive 3. So this equation has a greatest common factor. That actually should always be the first thing you look for, is to see if you can divide all of your terms by something they all have in common. Once you do that, then you look to see if it meets your 2 conditions. So now inside this parentheses, I have subtraction, and I have x squared, which is x times x, and 25, which is the perfect square of 5 times 5. So now this factors has my greatest common factor, and then it factors to x plus 5, x minus 5. Don't forget it's equal to 0. And then the next step, now that I've got it factored, is to set each factor equal to 0. Well, notice I actually have 3 factors here. I have a 3, an x plus 5, and an x minus 5. So just for illustration purposes, I'm going to set each factor equal to 0. So 3 equals 0, and then x plus 5 equals 0. And x minus 5 equals 0. But then I'll notice one of these statements can never be true. It's never true that 3 equals 0. So that means this factor of 3 does not affect my answer. My answer will come from my other two factors. X plus 5 could equal 0 if I subtract 5 from both sides. And I get x equals negative 5. So negative 5 plus 5 equals 0. So that's a possible answer. And then the other answer would be to solve this equation, which can be solved because I can add 5 to both sides, and I get x equals positive 5. So anytime you have a greatest common factor that is just a number, that number will not give you your solution because that number can never equal 0. All right, let's look at number 4. Number 4, I have 9x squared equals 27x. So this is a quadratic equation because my highest exponent is 2. The problem with this one, though, is it's not equal to 0. So what I want to do is make it equal to 0. So I'm going to subtract everything away from one of the sides. In this case, my 9 is positive. So I've got a positive x squared term. I want to leave that one alone. And I'm going to work with the 27x and make that equal to 0 by subtracting 27x from it. When I do that, I get that equal to 0. But whatever I do to one side of the equation, I have to do to the other side of the equation. And so now what I have on the left side of my equation is 9x squared minus 27x. So again, I'm going to look at this and go, okay, this will have two answers. I can solve it by factoring. It is subtraction, but it is not perfect squares, so I'm going to look for a greatest common factor. In this case, both of these terms, my smallest number is 9, and 9 does divide into 27. And also, both of these terms have an x, and my smallest x is x, so I'm going to factor out a 9x. So I'm going to bring out a 9x, that's my greatest common factor. And what's left here is 9 divided by 9 is 1, x squared divided by x is x, negative 27 divided by 9 is 3, x divided by x is 1. So I get 9x times x minus 3 equals 0. Equals 0. Now I have two factors here. I have a 9x and an x minus 3. Both of those factors have an x in them, so both of these factors can be set equal to 0 and I can find an answer. So I can set 9x equal to 0 and solve that, and I can set x minus 3 equal to 0. So anytime you have a greatest common factor with an x in it, you can find an answer using that greatest common factor. Because to solve this, I just have to get rid of this 9. That 9 is being multiplied by x, so I just divide both sides by 9. 0 divided by anything is 0. What that means is one of my answers is x equals 0. And then my second equation here, x minus 3 equals 0, is easily solved by adding 3 to both sides, and I get x equals 3. So this equation also has two answers. The answers are 0 and 3.